Today, we would like to talk about inner products of two-dimensional vectors on a plane. Linear Algebra 101, Section 1.6. What is the inner product of two vectors in 2D space? Please note that this presentation is a slow-track approach that carries detailed steps. However, it is DIY. You do it yourself by finding more information in the books or on the internet, please. We may modify two scalars or integers together, but when it comes to vector components, it is very difficult. But why? It is easier to approach this issue at hand from algebraic perspective. Question: how many ways can we form the multiplication of two vectors, u and v? In this presentation, we assume the following vector denotations. U equals u1, u sub 2, v equals v1, v sub 2, sometimes enclosed by the square bracket, sometimes by a pair of parentheses. First of all, there are two different kinds of vectors for 2D space, to say the least, row and column vectors. We also need to ask if we should define any product of two vectors. Is it well defined? In this presentation, we are going to use row vectors as examples for the time being. Think about how many combinations of multiplication and addition of the components of the two vectors there are. U and V, with u sub 1, u sub 2, v sub 1, v sub 2. Traditionally, mathematicians define the following three products of two vectors of 2D space: inner product, or dot product, scalar product, cross product, and outer product. Inner product of two vectors, aka dot product, scalar product. It takes two vectors and produces a scalar or number, thus going from the 2D space to the 1D based space. Hence called inner product, going inside the base. Inner product of two vectors in vector component form. U vector U, inner product V vector equals u1 v1 plus u2 v2. Geometrically, U inner product V equals the length of U and the length of V cosine theta, where theta is the angle between the two vectors. In the vector form may come from randomly multiply the two aligned components together in a vector component form. Geometrically, the cosine, length cosine form give us some ideas of whether the two vectors are perpendicular or not. As we can see here, if the two vectors are orthogonal or perpendicular, then their inner product equals 0. This is a wonderful property produced by the inner product. Check the following two simple vectors and find their inner product by also drawing the vector on the 2D plane. U equal 1, 0. V equals 0, 1 on the 2D Cartesian plane. Actually, they line up with the x-axis and y-axis respectively, hence perpendicular or orthogonal. Draw the picture yourself, please. The two vectors that we just saw actually have the angle between them of 90 degrees or half pi, unit in radians, half pi. And you can tell it's a quarter of a circle going through the arc. Now, because the cosine theta, where theta equals 90 degrees, the value of cosine theta equals 0, a big, huge 0. Therefore, geometrically, the inner product of two 2D vectors may also represent the angle between the two vectors. Once you draw a line segment from the origin to the point in 2D space, then place the arrow at the end of the line segment. Another geometric figure, the inner product of two vectors, may represent the square of length of a vector on 2D plane. And another one is the projection, as you can see here. Thank you very much. And you will see again and again the projection vector from A to V in the formula. So please take a look again. Thank you for your patience.